Welcome to Study Loop.
Hello everyone, today we're doing chapter 14, problem 2, and this question states that we have a proton NMR spectrum for this molecule here, 1,2-methoxyethane, and we record the NMR spectrum using a 300 megahertz magnet, and we get two signals. One signal from the molecule is 1017 hertz, and the other signal is at 1830, it is at 1065 hertz downstream from your reference TMS 0.0. So part A asks you to calculate the chemical shift for each absorption value, and part B asks you at what frequency would each absorption occur if the spectrum were recorded on a 500 megahertz magnet. So if you recall the equation to determine your chemical shift, so your chemical shift, or delta sign, equals your observed chemical shift value, and this is in hertz, and this is divided by the operating frequency of your NMR in megahertz, so the magnet strength of your NMR. So if we plug this equation in using the information we have provided, so for part A, we're asked to find the chemical shift value. So we know that for this signal here, the 1017 signal, our chemical shift equals our observed chemical shift at 1017 hertz divided by the operating frequency of our magnet being 300 megahertz. This gives us a chemical shift value of 3.39 ppm. And then for the second value, we get a chemical shift equals 1065 hertz, and that's also in the 300 megahertz magnet, and that gives us a chemical shift value of 3.55 parts per million. But now what happens if your magnet strength increases? Well, the whole beauty of this chemical shift is that regardless of the strength of your magnet, your chemical shift will stay the same. The ratio between your observed shift and your frequency of magnet, that ratio will always be the constant. So if you have a stronger magnet, then you need higher energy to cause that spin flip to happen. So the ratio will never change, but these arbitrary values will change. But that's why we use the chemical shift value, because it's unanimous regardless of your strength of the magnet. So for B, now we're trying to find, so B asks us what happens if we use a 500 megahertz magnet. So we know that for A, the 1017 signal in A, this part here, we had a chemical shift value of 3.39 parts per million. So what's our new observed chemical shift if we use a 500 megahertz magnet? And well, our hertz value will be 1695. And if I use the same equation for the bottom value, our unknown is a hertz, we're using a 500 megahertz magnet, and our new observed value is 1775 hertz.